Hey, hello everyone. Welcome to today's edition of the Grafana Agent Community Call. I'm Paschalis. I will be your host for today. This talk will be available on Grafana's YouTube later on. So if you want to be seen or heard, then consider this your warning. And in today's agenda, we have two main topics. First, we're gonna present a new way of how we plan to utilize like BI data to understand the usage of beta features in the agent and how it can help us plan our next releases, plus some data around the agent's hardware requirements as we scale up. We would also like to give a small update on how Flow is going. If you have no idea about what Flow is, it's a new way of configuring the agent that is going to be a beta feature in the next few months. We dedicated the whole episode of the community call I think the last community call. So if you're interested about that, you can go there and check it out. So without further ado, should we move on to the first topic? Mark, do you want to take over?
Yeah. So let me share the screen. This one. Okay, so I want to show you what we added in the last release of the agent, which is the version 0.25. And we basically added the ability to report all the usage of the feature flags that agent users can configure. So this will help us to identify which feature flags are being used more and prioritize if we want to promote some of these features from experimental to like a more stable uh, yeah feature, right? So by default, we decide to be this opt-in opt out. So by default is enabled. We follow the approach of other projects like Loki, and in this in this documentation we can see like a bit of explanation about this, which basically we are sending this data, which by the way is completely anonymous. It's there's nothing that we track, and we send these statistics to our internal clusters. And if you by any reason you don't want to report this data, you can use this flag and it will disable the reporting. So that's it. We encourage people to keep using this reporting because it's going to help us to have better insights of adoption of features, and maybe in the future we will use for other statistics. Yeah. So I think that's it. If anyone has a question. Yeah, Robert?
Can you talk a little bit about why it became opt out instead of opt in?
Right. So there was like an internal discussion about that. So the Loki team initially decided to, well, they added this like before us, and they did like as opt in, and after the rollout of this, no one enabled the feature. So they decide to do it opt out because they didn't have any data after a couple of weeks or months of having this feature uh, yeah ro- deployed, right? So that's why yeah other people in Grafana encourage us to follow the same approach. uh, can we see the dashboard? uh, yeah, we don't have the feature flags, but we could see, yeah, the number of reported installations and so on.
Will you be saying? Okay.
Yeah. So yeah, this is the dashboard so far, and yeah, as we will see, this is yeah, we can see the different versions that uh, that are being reported, and this is the yeah where the agent is being used, different operating systems, and the future we're gonna have here the number of feature flags used.
I
We don't
imagine
keep
like all the
any.
main. Sorry, Pascal. Go ahead.
No, we don't keep any like detailed geographical data. This is all ballpark estimates about where an IP
Yeah.
came from the
Yeah.
request. And all we're gathering is just the version of the agent currently running and what kind of flags they've passed in at the command line. Go ahead, Robert. Sorry for interrupting.
I imagine like all the main versions and like the release candidate. That's probably us, right? Rather than external users.
Yeah.
Yeah. I mean, I think it's really interesting how like the OS breakdown happens, where we have like way more Windows users than we have any Mac users.
Yeah. Yeah. 30, 218, and the rest Linux.
Nice. Thanks for showing, Mark. I like this.
Oh, thanks.
Nice work, man. Does anybody have anything else to add on this? I'll take that as a no. And we can then quickly move on to the second item on the agenda. Like a long time ago, the idea floated around that we weren't really aware of the hardware requirements of the agent. And that meant that we could have some ballpark estimates regarding our internal usage, but we could not extrapolate that to how the agent would react when scaling up. So in order to test that, we provisioned some environments where we could deploy a standalone agent and stress it up to like 14 to 16 million active series. That means it's actively recording data. And then in a more real life scenario of having like 400,000 series, we wouldn't ever recommend you running the agent with that kind of load. You would be much better served by using some clustering method from our documentation page. But nevertheless, these are some first data that we'd like to share with the community. This was heavily inspired by what Prometheus does with Prombents, which automatically can, not automatically, but using a GitOps approach, can serve data about the performance, how a certain PR affects performance of Prometheus. And maybe in the future, we could have something like that for the agent as well, like being able to quantify a regression or an improvement right there in the PR. Are there any specific questions before we go ahead and show the results?
I'll have questions, I think, after we see the results, but yeah,
Okay.
let's see it.
Give me 2 minutes. I should be able to share my screen like this. Can you see it now?
Yeah.
Okay, so this is the internal benchmark that we run. The first one is the more active one with 14 to 16 million active series. And the second one is the more realistic scenario. We're measuring things like OS hardware usage levels, like memory and CPU, disk space usage, network rates, file descriptors. as well as how the wall size oscillates when it is checkpointing data or is clearing um, all their entries. How the bytes per series metric runs over time. That means how much memory the agent consumes per active series, as well as some Go-specific metrics about how many Go routines are running to verify that there's no leaks, or if the garbage collection takes up a certain amount of time and does not explode for some reason. And after getting all this data and having an agent that solely scrapes metrics and send them over to some remote write, there's no clustering going on. There's no filtering of other targets metrics happening with reliable filtering, no logs or traces. We've come to the conclusion that for a 100,000 series, sorry, that's incorrect here, uh, it seems like we'd recommend you running with at least 0.01 cores. That might sound stupid, but if you can configure that limit in Kubernetes, then it might make sense. About 0.6 gigabytes of memory and half a gigabyte of disk space. Go ahead, Robert.
So when we say cores here, like, can you talk a little bit about, like, the specific hardware specs we were using? Like, what type of CPUs were these?
Yeah, thanks for that. Basically, we did all this to standardize around the virtual CPU units that the Google Cloud provides. So we used a standard 8-core Google Cloud provision machine. I'm not sure how this fares between different cloud providers, if it's comparable between AWS and Google Cloud or Azure, for example. But it's for whatever definition of a virtual CPU from Google Cloud is using.
Gotcha. Thanks. Do you want to talk a little bit about the implementation details here, like what the kind of architecture looks like, how we're doing the tests, so on?
Yeah, uh, yeah, that would make sense. Just to reiterate, this is like something of a minimum requirement. It's an agent that doesn't do much, but hopefully it's something that we can use to benchmark future releases in the future and try to improve upon. To obtain this data, we use two machines in the same GCP subnetwork to avoid latencies or other network issues. The generator machine was generating metrics using Avalanche, uh, and basically two sets of metrics, one more stable one that only whose sample values would fluctuate, and one set of metrics that would go away over time and come back with different label set to simulate a more realistic scenario like container labels on pods or something like that. The runner machine, the second machine, which was just running the agent on an Ubuntu 20.4, if I remember correctly, instance and nothing else, was scraping 5 copies of the first endpoint and then one copy of the second endpoint. And it was just dumping the data on a fake remote write endpoint that always returned immediately with 200 OK code. And to obtain this data, we also enabled the process in node exporter integrations so that we were able to get this data back to Grafana Cloud and show them into a dashboard without incurring extra load and contaminating the results. Let me see if there's anything more specific. We have recorded the commands used to generate the avalanche metrics and the configuration for the agent. So once this document is public, then maybe someone could they could replicate these results if they wanted to. But I think that's pretty much an overview of how this data was obtained. Any other questions?
I love this. Thank you. I see that privacy says currently internal. I imagine we're gonna like publish these probably every release or something like that. What do you think?
Yeah, I think that would make sense. And tying it to an automation process, that would be something that would be really helpful for the squad.
Cool.
Okay. To avoid a longer awkward silence here, I would like us to move on to the third part and to provide a small update on how Flow is going. Again, Flow is a new experimental feature that we're bringing into the agent that will allow you to configure the agent uh, in a different way and allow us to map the agent configuration more into the mental model of how a user would like it to work instead of replicating Prometheus compatible YAMLs in duplicate over and over again. Does anyone want to take the stage here and express their opinions? Okay, then let me give a short update. So we right now we have merged into main the logic of how flow components should work, and are currently using HCL as the base of the configuration language, um, plus two more components. One that can read the contents of a file from the disk, and one component that can mutate targets based on reliable configs that come from a service discovery component. Our plan for the next few months is to build an MVP that can replicate the current functionality of scraping metrics, storing them in a write-ahead log, and sending them over to remote write, and be able to do that solely with flow components, and being able to evaluate how that works for the developer, for the user, from performance perspective, and all that. So yeah, if that sounds interesting to you, I think that there's more good stuff on the way. You can either wait a few more releases to really get to see how it will work for you, or you could check out the main branch and see what we're currently building. There's work to be done. So if you even want to contribute, it's open source, and we'd love for more people to join in on the fun. Go ahead, Robert.
So right now, all the flow code isn't in the normal agent command. There's a separate command we're
Yeah.
working with for prototyping. But when we're ready to release it as an MVP, it'll be in the agent command with a flag to enable it. I don't know what release that'll be. Probably like 2027. Probably not 26 though. Within the next few months is the hope.
Yeah. And again, this is not something that, as Robert said, that is going to impact you in any way. It's going to be an experimental way for you to be able to have more control of over what the agent does, and to allow you to tie all the different components in new and novel ways. Does that sound okay to you guys?
Yeah, sounds good. I'm excited.
I think there's fun stuff coming up, yeah, and getting the community involved in it in these early stages would also be like super nice. Okay, I think that's the agenda for today. Does anyone else have an extra topic to bring on here? Something that popped into your mind in the last minute? Okay, then I'll probably see you in like 6 weeks, right?
And it's every 4 weeks.
Every 4 weeks. Okay, sorry for that. Okay,
Bye.
see you. Bye.